Have you ever wondered where the universe ends or if it even has an end? This question stirs curiosity and sets us off on a journey to explore the concept of an infinite universe. It's a notion that challenges our understanding and stretches our imagination to its limits. Imagine for a moment a balloon. Now, envision tiny dots representing galaxies on the surface of this balloon. As the balloon inflates, the dots move further apart from each other. This is a simple but effective analogy of how our universe is constantly expanding. And in this expansion, there may not be a definitive edge as we might perceive it. The universe's expansion isn't just a wild guess or a fanciful idea, it's a theory backed by substantial scientific evidence and observation. Scientists have observed that galaxies are moving away from us in every direction. This observation suggests that space itself is expanding, carrying galaxies with it. But where did all this start? What set off this cosmic expansion? To answer that, we look back to the idea of the Big Bang. This theory suggests that the universe has been expanding from a single infinitely dense point. This point, smaller than a pinhead, contained all the matter that makes up the galaxies, stars, planets, and everything else we see around us today. With a Big Bang, this point began to expand, and it's been expanding ever since, for approximately 14 billion years. However, the notion that the universe is infinite and forever expanding poses some mind-boggling questions. If the universe is infinite, what does it expand into? And if it has no edge, where does it begin or end? These questions force us to reconsider our understanding of space and time. They challenge us to think beyond our everyday experiences and confront the mysteries that the cosmos presents. It's a fascinating journey, one that invites us to explore, to learn, and to marvel at the wonders of our infinite universe. The universe's expansion challenges our understanding of space and time. If the universe is infinite, then how much can we actually see? It's a question that stirs the curiosity of scientists and stargazers alike. To answer this, we'll need to delve into a concept known as the observable universe. The observable universe, in simple terms, is a giant spherical region of the universe that contains everything we can observe from Earth at this moment in time. Picture it as a colossal cosmic sphere, with our planet at the very center. Everything we've ever seen, discovered, or studied in space lies within this sphere. From the closest planets in our solar system to the most distant galaxies captured by our most powerful telescopes. But why can't we see beyond this sphere? Well, the answer lies in the speed of light. Light travels at an incredible speed of roughly 186,000 miles per second, and yet, even at this speed, it takes time for light to reach us. The light we see from distant stars and galaxies is not how they appear now, but how they looked when that light left them, often millions or even billions of years ago. This means that when we look at the stars, we are not just looking through space, but also through time. As fascinating as this is, it also poses a limit to what we can observe. There are parts of the universe where the light hasn't had enough time to reach us yet. Because of the universe's age and the speed of light, these regions lie beyond our observable universe, but let's not downplay the size of our observable universe. It's estimated to be around 93 billion light-years in diameter. That's mind-bogglingly vast, filled with approximately 2 trillion galaxies, each brimming with billions of stars. And yet even this enormous expanse is but a tiny fraction of the infinite cosmos. So, while we can't see everything, we can marvel at the enormity of what we can see. Our observable universe, vast as it may be, is just a small fraction of the infinite cosmos. What lies beyond what we can see? This question has captivated the human imagination for centuries, and as our scientific understanding of the universe has grown, so too have the theories about what might exist beyond our observable universe. The theory of multiverses, for instance, suggests that our universe may just be one of countless others. Each one is like a bubble, floating in a cosmic sea of other bubbles, each with its own laws of physics, its own galaxies, stars, and potentially life. This theory posits that our universe is not unique, but rather one of an infinite number of universes, each as real and as vast as our own. But how do we arrive at such a mind-boggling concept? It all comes from our understanding of the Big Bang. If the universe started from a single point and has been expanding ever since, then it's logical to think that there could be other points of expansion, other Big Bangs, that have given birth to other universes. However, these are just theories. As of now, they remain unproven. We have yet to develop the technology or the means to observe, let alone explore, these potential multiverses. But that does not diminish their importance. Theories like these expand our understanding of the universe, challenge our perceptions of reality, and remind us of the vastness and complexity of the cosmos. So, what lies beyond our observable universe? The answer is, we don't know. Our current understanding of physics, space, and time only allows us to observe a certain portion of the universe. There could be other realities, other dimensions, other forms of life, or other universes, all beyond our current capacity to perceive or understand. And yet the allure of the unknown is what drives us to keep exploring, to keep questioning, to keep pushing the boundaries of our knowledge. Because it's in that exploration that we find not just answers, but more questions, more mysteries, more wonder. Beyond our sight could be an infinite number of possibilities waiting to be discovered. So, does the universe have an edge? Well, that's a question that has puzzled astronomers and philosophers alike for centuries. When we think of an edge, we usually imagine a boundary, a point beyond which nothing exists. But when it comes to the universe, things aren't quite that simple. You see, the universe as we know it is not a finite entity with a defined boundary. It's an ever-expanding expanse of galaxies, stars, and cosmic dust, stretching out into what seems like infinity. In an infinite universe, there would be no edge as such because by definition, infinity has no end. But let's take a step back for a moment. When we talk about the edge of the universe, what we're really referring to is the limit of what we can currently observe and understand. Our observable universe is limited by the speed of light and the age of the universe. The light from stars and galaxies billions of light years away is just reaching us now, giving us a glimpse into the universe's past. Yet there's still a vast portion of the universe that remains unseen, unexplored. These regions beyond our cosmic horizon are as mysterious as they are intriguing. We can speculate and make educated guesses about what lies beyond, but until we find a way to observe or reach these regions, they remain a part of the universe's edge. The edge of our knowledge, our understanding, our observations. And here's the fascinating part, this edge is not static, it's constantly moving, constantly expanding. As our technology advances, as our understanding deepens, we push this edge further and further out into the cosmos. We are, in a sense, explorers charting the uncharted, pioneers on a cosmic frontier. And so we come back to our original question. Does the universe have an edge? Perhaps a better question would be, where's the edge of our current understanding of the universe? And to that, the answer is clear. It's out there in the vast, uncharted expanses of the cosmos, waiting to be discovered. The edge of the universe is constantly moving, just as our understanding of the universe is. What's next in our quest to understand the universe? Well, the future of space exploration and cosmology is as vast and exciting as the universe itself. Filled with upcoming missions, revolutionary telescopes, and groundbreaking technologies that will undoubtedly transform our understanding of the cosmos. As we step into the future, we anticipate a new era of space exploration. NASA's Artemis program, for instance, aims to return humans to the moon by the late 20s, paving the way for future manned missions to Mars and beyond. Similarly, the European Space Agency's Athena mission, set for the early 30s, is poised to delve deeper into the mysteries of black holes and the formation of galaxies. Meanwhile, in the realm of telescopes, the upcoming Square Kilometre Array, an international effort to build the world's largest radio telescope, is expected to provide new insights into cosmic phenomena, from the mysteries of gravity to the nature of dark energy. The James Webb Space Telescope, on the other hand, will peer back over 13.5 billion years to see the first galaxies formed after the Big Bang, offering us a glimpse into the very infancy of the universe. And let's not forget the role of emerging technologies. Quantum computing, artificial intelligence, and advanced propulsion systems are just a few of the innovations that could revolutionize how we explore and understand our universe. These technologies have the potential to process astronomical amounts of data, make autonomous decisions in deep space, and propel us to far-off celestial bodies at speeds we could only dream of today. But perhaps the most important aspect of our future exploration is the continuation of our curiosity and our relentless pursuit of knowledge. We must continue to question, to explore, to seek out the unknown. For it is in the unknown that we often find the most profound truths. As we continue to push the boundaries of our knowledge and technology, Who knows what we might discover about our infinite universe?